There we go, there's the page I want to start on. You can take out your highlighter. Here is the definition of what a trigonometric identity is. We will affectionately call them trig identities. A trig identity is something that's always true for all values of theta. And we have learnt some of these already in the big ideas that we've had from our last unit, chapter 6. What's one of the big ideas that has, what was one of our big ideas? Sine squared of theta. Sine squared of theta plus cos squared of theta is equal to 1. This is an identity because it's a trig equation that's always true. Sine squared plus cos squared of any angle is always equal to 1. What's another big idea that we've learned? Has to involve a trig ratio, though. What do you know about tan? What's tan always equal to? Sine of theta over cos of theta. And so what's going to happen with our identities unit is we are going to take the identities we already know. Sine squared plus cos squared equals 1. Tan is sine over cos. Cotangent is cos over sine. We're going to take the ones that we already know. We're also going to take our definitions of, here they are, our definitions of our reciprocal functions. So you know that cosecant is 1 over sine, secant is 1 over cos, and cotangent is 1 over tan. For these ones as well, I would like you to say, if I know that cosecant is 1 over sine, then sine is 1 over cosecant. And if secant is 1 over cos, then cos is 1 over secant. And if tan is cotangent is 1 over tan, then tangent is 1 over cotangent. If we have these ideas, if we have our reciprocal identities and we have our big ideas, these become our tools. And what we're going to do in this unit is we are going to prove other identities. And so the way that it works for us is we have a certain amount of tools, all of the reciprocal identities, sine squared plus cos squared equals 1. Tangent is sine over cos. We're going to be able to use those tools to prove other ones. And it's going to sort of be like solving a puzzle. They also have here in your textbook, if you take some of these equations, can you see if you take cosecant equals 1 over sine, and you multiplied both sides by sine, then cosecant times sine is equal to 1. That would be a new identity that could be discovered or obtained by rearranging that old identity. We also have that secant theta times cos theta is equal to 1. And cotangent theta times tangent theta is equal to 1. So I'm going to hand out a paper to you guys. We are going to do a couple of them together. And then I'm going to get you to work on them on your own as a start. On this sheet, they start off relatively easy. So if we do number 5, before we get started, we need to learn some of the rules for doing identities. and how we're going to write them out and how we're going to prove them. So in each of these questions it says prove. In a proof, what you're trying to show is that two things are equal. This one here says cos of t times secant of t is equal to 1. So the first thing you're going to do is rewrite the question, and where the equal sign is, you're going to draw a line. Because you're not allowed to use the fact that they're equal, because that's what you want to prove. So the rules of proving identities is you're allowed to work on the left side of the equation and manipulate things. You're allowed to work on the right side of the equation and manipulate things. And it's a puzzle. And the puzzle is, can you make both of them the same? So when we're looking at the left side, because it looks like there's more things that you can change, what do we know that secant is equal to? Secant is equal to 1 over cos. So our first step is we might change secant to 1 over cos. And sometimes you won't know what you should do, and you'll just try something. And the more practice you have, certain things will come up as strategies that will lead you towards doing one thing over another. By changing it to 1 over cos, now I have two things multiplied. I have cos t, which I could write as cos t over 1, multiplied by 1 over cos t. So now we would say, well, let's multiply those. Yes, I could simplify, because this cos t would simplify with that cos t, and this side would just equal 1. And we've solved the puzzle. Now the left side is equal to the right side. As a final thing for solving the puzzle, we make a statement that says we have solved the puzzle. The statement looks like this. Do you know what those dots mean if you write that? That means therefore, which is the weirdest thing in the world, because how many dots are there? 3, not 4. But we say therefore. I don't know. Okay. There 3 would be better, but no, they say therefore. So it's so confusing. Therefore, the left side is equal to the right side. So you need to make a statement to say that you have proven what has been asked. Now, after this, I like to add some fancy math stuff. So the fancy math stuff that I like to add after saying the left side is equal to the right side, I like to go QED. Okay? The QED is very typical at the end of a math proof. It's an abbreviation in Latin. So I'm going to butcher some Latin here in a second. Okay? Most people don't know how to speak Latin, so this makes this really nice to use. Quod erat demonstratum, which basically said what was asked to be shown has been shown. What is asked to be shown has been demonstrated. So it's kind of fancy for saying, I have demonstrated what I have wanted to prove. And then my own personal touch after this is I like to make a little square box and shade it fancy on the one side. Just something pretty. Maybe you put a little circle with a smiley face, some sort of hashtag that's you at the end of your proof. I like to make a little box with a square. So I think the reason that I do the little square box with a little shading is one of my university textbooks had all of their proofs ended with a little square box with it, right? Sometimes, especially some cultures in all math, when they finish their question, they show that they finished their question. Does anybody ever do something like this at the end of their question? Have you ever seen something like that? Yeah? So some places they teach whenever you're done a question to make some sort of mark to show that you're done a question. In mathematical proofs in the textbook I had, it had a little square with a box. Some magazines use this for articles. They have a little emblem that when they put that emblem, you know the article is done. Especially because now magazines, you ever read a magazine, it's like the article starts on page 1. On page 2 to 15 are advertisements. And then on page 16, you get a little bit more of the article, and then another 15 pages of advertisements. So you're like, when will I ever find the end of this article? So magazines often have a little symbol to say, You don't have to keep looking. We're done. We've finished the article. Okay, so let's do another one. We're going to skip a few. We're going to do number 12. Number 12 says secant of theta divided by secant of theta divided by cosecant of theta is equal to tan of theta. This is what we've been asked to prove. So once again, we draw that line. So the first thing you're going to do is you're going to rewrite the question and draw the line. The reason that line is there is you're never allowed to move from one side of the equation to the other. The only time you can move from one side of the equation to the other is when you know that equation is true. And we've been asked to prove this equation. So the only thing we can do is work on the left side or work on the right side. And one of the key strategies that you're going to learn early is that if you look at all of your trig functions that you have, they can all be manipulated to change to just sine and just cos. For example, what could I change secant to? 1 over cos. I'm going to draw this line thicker. Cosecant is 1 over sine. Okay? Now you're working on line paper, right? I gave you loose leaf. Before you write too much right here, or before you write this step, I would like you to make sure you have a space there. Just a little space, maybe one line. And the reason that we're going to use more space for these is you want to be able to see that this clump is equal to this big clump. And then we're going to leave a little bit of space here as well, so that otherwise, with all the fractions inside of fractions inside of fractions, things are going to get lost. And you're going to start to accidentally put things together that shouldn't be put together. So we're going to add some space. What about on the right side? Can you change tan to something? Tan is equal to sine over cos. So a strategy that we're going to have is, can you change things to sine and cos? And after you change things to sine and cos, well, then the strategy we talked about at the beginning, which will work so many times, is can you write both sides as a single fraction? Can you see that the right side is a single fraction? But the left side isn't yet. It's a fraction over a fraction. So we're going to use our fraction rules. How do we divide? Multiply by the reciprocal. So we would write 1 over cos theta multiplied by sine theta over 1. How do we multiply fractions? Multiply the tops, multiply the bottoms. So then this becomes sine theta over cos theta. At this point, we've solved the puzzle. Can you see that our left side is identical to our right side? And so now we can make the statement, woohoo, there's 4 of them. Left side equals right side. Add the fancy stuff. Right? Oh, nice. Yes?
Which is the limit of the symbol we can draw? I mean,
Well, don't make the Mona Lisa if it takes you like 5 hours to draw at the end, right? Something simple, right? Right? Maybe you add your initial inside of the box to make it yours. Okay.
Do you actually have to do that?
Do you have to do the symbol? If you don't write the left side, you have to write the left side is equal to right side to show that you know that you've proven it. Okay? They are not going to take off final marks on your exam if you don't have Latin or you don't have a symbol. But this just makes, in my opinion, makes it nice, makes it pretty.
Makes it official.
Makes it official. It's kind of fun. It's kind of fun. And you will be, the These ones aren't too bad. The proofs will get hard. And when you finally get your proof at the end, you will be excited. And so take a moment to enjoy that time,
Before you go to the next one.
right? Make something nice.
So you can use this to prove anything mathematically.
So what we now know, that anytime you take secant and divide it by cosecant, it's equal to tangent. And we've proven a new identity. What we have is there are certain identities that you are allowed to have in your toolbox. Your toolbox includes all the reciprocals. That tan is sine over cos and cotangent is cos over sine. That sine squared plus cos squared is equal to 1. That's what's in your toolbox. Eventually, we'll add a few more. You can see that there's some up on the bulletin board over there. They're on your formula sheet. You're allowed to use those in your toolbox as well. Right? You can't just say, oh, and this happened on a final exam. There's a really complicated proof. And what the person said was, ladies and gentlemen, it is obvious that blah, blah, blah is equal to blah, blah, blah. No extra work needs to be shown. This proof is done. And they got 0. But it was very enjoyable to read because they had no idea how to prove it. So what we're going to have is we're going to take the next little bit. We're going to work on the first ones. I think you can get to probably around 20 or 21 with the tools that we have. And then we'll start running into problems. And then we'll have to look into some strategies and some other things to make it work.
Are those 3 points, therefore, points, each an international symbol?
I don't know if the 3 points is an international symbol. I'll look it up. We'll see what I can find.